So this rather space-age instrument behind me here is actually a tool that we use to measure atmospheric radiation. Now, sometimes when you hear the word radiation, you tend to think of, oh my goodness, an alarming thing. Well, this happens to be solar radiation, sunshine, and it also is a measurement of terrestrial radiation, that is radiation that the Earth basically emits into space. So we measure both what is incoming from the sun and what is outgoing from the Earth. And with this instrument, we can then basically measure the radiation budget, is what we call that, this measurement. Now, the radiation field around you is actually rather more complex than you might think. If it's a completely clear day, then there's going to be the sun's disk up in the sky, and there's going to be some blue sky around that, but almost all of the solar radiation on that clear day is going to come from the sun's disk, basically. That part of the sky that houses the sun's disk, that's what we call direct radiation, and that's going to be predominant on a clear day. There'll be blue sky, and there'll be some radiation that's scattered in from other directions, but most of the energy is going to be in the direct part of the spectrum. When we have clouds in the sky, the field changes quite appreciably, and actually in that particular case, a good example is today, the field is almost completely diffuse. That is, when you look at where does this radiation centered, where is most of it coming from, we think it's coming from everywhere. So it's basically a diffuse radiation field. So what this instrument does is this instrument measures radiation, and it divides that radiation into the direct and diffuse field. And what this very sophisticated looking tracker, basically this tracks the movement of the sun, and these little balls actually shade, they actually put shadows on two of these radiometers so that they're always measuring everything other than what's coming directly from the sun. The one that's unshadowed actually measures that direct component of the radiation. Okay, so by dividing the radiation field into direct and diffuse, you might say, well, why do we care about that division? And the answer is, well, things like collecting radiation with solar panels depends highly on the nature of the radiation field. So that's one application. Another is that in models, and when we try to represent the atmosphere in models, in numerical weather forecast models, we have to know how much radiation is outgoing and how much is incoming through cloudy skies, and that comes down to knowing how much direct and diffuse radiation reaches the surface over a given area.